12 candidates in a city election. The winner is mayor, the runner-up will be vice mayor. How many different combinations of mayor and vice mayor are possible? Well, that's a dirty lie. It's not a combination at all, because order matters. It is in fact a permutation. We use that term sort of interchangeably, but you got to look for it and you got to be aware of it. So since it's a permutation, there's 12 items taken 2 at a time, and it's a permutation, meaning there's only one denominator here. So you've got 12 factorial over 12 minus 2, which is 10 factorial, which means you've got 12 times 11 times 10 over 10 factorial. I'm sorry, those are, they keep going. 10, 90, 10, 90, 2, 1. So you cancel those, bada bing, bada boom. You get 12 times 11, which is 132. You kind of, in this case here, you could have said there's just 2 positions available. There's 12 people that could get that mayor position, and once the mayor is elected, there's only 11 left that could be vice mayor. You end up with the same thing. With a permutation, there's 2 different ways you can sort of approach it. But when you look at something like this, and I want to do 79 and 80 together because they sort of apply. Teresa and Julia are among 10 students who have applied for a trip to Washington, D.C. 2 students form the group, or from the group, will be selected at random. Okay, so there's only 2 that are going. They're both going. One's not going and the other one's vice going. Okay, there's no order that matters here. The probability that Teresa and Julia will be the 2 students, well, it's only one way out of the total number of different ways you can group 2 people together. That's one way of looking at it. You can say it's a combination of 10 people taken only 2 at a time. To do that, it's going to be a 10 factorial over 8 factorial and 2 factorial. So when it's a combination, you've got the difference here represented by the 8, and you've got that guy that also goes here. So when you extend and simplify 10 times 9 times 8 factorial, you stop there because you happen to have another one down here to cancel. Then you have the 2 times 1, which is the extended 2 factorial. Cancel, cancel. 2 goes into 10. 5 times. Well, now you have 5 times 9, which is 45. That's how many different groups of 2 that can be formed. When you're asked what is the probability that these specific 2 individuals, well, that's only one pair out of all the pairs that could be formed. So the chances are 1 out of 45. Well, it's a different way of looking at it. Just so that we're looking. We saw the different way down here. A different way of looking at this would be to simply say, well, what are the chances that either Julia or Teresa are selected from the 10? Well, there's 2 girls that represent Teresa and Julia out of the 10 people. I don't know which one I picked, but let's say I picked one and I go back, what are the chances I pick the other one next? Well, there's only one left out of the 9 people available. Reduce that, 1 over 5. That'll give you the same 1 over 45. So a couple different ways of looking at both problems.